Enthusiasm, I love it. I'm so glad you're out here today. Welcome you to Somerset Community College, our Valley Oak campus. This is the latest addition to the college, and one which I think you can kind of see is devoted entirely to workforce solutions and developing workforce employees. We do everything from underground and overhead utility, heavy equipment operations, truck driver training next door, advanced manufacturing, all those kinds of things out here. So we're really excited to show this off to you as well. And I just wanted to start out with just a couple comments, and then I'm going to introduce you to a few people who have been really integral to making this thing work. And so it's going to be I think, an exciting morning. I think you've probably seen a lot of what's going on already, but let me just get kicked off here. See, I am really very proud of our people, their purpose, and their success here in Kentucky. This event is just one of many ways that we show how we are working with our community to serve them and provide the best high quality, affordable, accessible education and training available in this part of Kentucky. Our whole focus is on growing workforce and developing and building employees to support what's going on in Kentucky and helping it become better. Without a doubt, this is one of the most significant events I've ever seen at SEC, and one they've produced that provides a huge amount of depth and application in our technical areas, and showing just how you can take something that seems very old and now make it very new again, and more efficient and better for everybody in the state. We are excited to have you here to witness Kentucky's first ever 3D concrete printed structure that is designed to resist high impact stress in a construction process that dramatically reduces build time. Floodbuster 1 serves as a working model of how construction might evolve to meet the challenges of the present and prepare for what's next. Floodbuster 1 is a product of collaboration between education, industry, and mission-driven partners, each contributing unique resources and expertise to bring this concept to life. Those partners include the Habitat for Humanity, Pulaski County, who contributed reference plans during the design phase and will furnish the completed home with appliances to help simulate a real-world living environment. SEC's heavy equipment operations, students and faculty who assisted in digging the foundation and footer of the home, supported by longtime program partners Brandeis Machinery, Boyd Cat, and Martin Contracting, who also donate and haul equipment for the HEO, the Heavy Equipment Operations Program. And OBH Renovations, who provided technical expertise and assistance, and IMI Concrete, which supplied cost-effective foundation materials that supported the project's efficient execution. RIC Technology is delivering the 3D concrete printing technology for Floodbuster 1, deploying the proprietary system to complete the structural print. And Progress Appalachia is providing strategic support and outreach, helping to connect to the project to broader conversations about regional revitalization and housing resilience. In addition to these partners, we have so many others that have supported SEC's additive manufacturing program, and I would ask that you take the time to see the list of partners on the J-Touch beside me. It's because of their support that we are able to do what you are seeing today. And now it's my pleasure to introduce you to Dr. Ryan Quarles. He is our fourth president of the Kentucky Community and Technical College System, and first native Kentuckian to lead the system of 16 community and technical colleges and 70 campuses. He was named president of the KCTCS Florida Region September 29th, 23, and began his position January 1st of 24. Dr. Quarles comes to KCTCS with a long history in statewide public service. He was first elected to the Kentucky House of Representatives in 2010, where he served until his election as Kentucky State Commissioner of Agriculture in 2016. His earlier work experience includes serving as an Associate General Counsel at Georgetown College and working in private practice. He is a ninth-generation Kentucky farmer at Quarles Farms in Scott County, and it is my pleasure to introduce you to my boss, Dr. Ryan. Well,
Thank you and good morning. How about a round of applause for not just Dr. Castle, but Somerset Community College? I think you're doing a great job. You know, I can't be up here and not mention this. KCTCS just celebrated the most graduates in the history of our community and technical colleges in Kentucky, with 24,000 students walking across stage, including those right here in this community. I want to say a spring welcome and want to say special thanks to some guests we have with us. We have a couple legislators, and forgive me if I've missed somebody. I know we have Representative Derek Lewis here somewhere. Representative Shane Baker is here as well. We have representation for Congressman Hal Rogers' office. Carlos is here. Thank you so much. Our mayor, great to see you, Mr. Keck. Our judge executive is here. The Center for Rural Development, and many others. So thank you all for taking time to come out and see something that really is novel and new for Kentucky, with the first of its kind 3D printed house right here in Somerset, Kentucky. What's really unique about this is that this is beyond proof of concept. This allows us to say, whether it's a natural disaster, whether it's addressing our affordable housing issue in Kentucky, whether it's about making sure that we have resources in areas of the state that need it the most, that we can literally grow or build something that is in high demand. And today's a unique day for me. I get to start seeing a robot building a house, and this evening I get to see our students compete against robot wars of horse parts. That's really neat. What's really neat about additive manufacturing is that this really combines high tech with working with your hands. And one of the most favorite advertisements I've seen recently was a building under construction that had a banner on the side that said, "Hey, Chat GDP, finish building this building." That we still have a high demand and need for people who work with their hands, and that's where our students, our community and technical colleges will continue to shine. I too want to echo all of our partners that Dr. Castle mentioned today, including USDA's Rural Development new State Executive Director Travis Burton. Congratulations on your appointment from our president. Additive manufacturing, this is just the beginning. Imagine the day when everyone owns a printer. Imagine the day as a farmer, I don't have to run to the parts store. I can just print whatever's needed. Imagine the day when we have on-demand need for parts and supplies. This is just the beginning. And so what's really neat about this opportunity is that it's being led by students. Students that are eager for new, high-tech, future jobs. We appreciate that. And before I leave the stage, this would not be possible without our own talented professor, Eric Woolridge. You are representing us across the country, actually, and helping bring in grants to help make this possible. So congratulations to all involved. I'm excited to see the house, and it's a robotics day for me. Thank you so much.
All right. Can we turn the air conditioning on? Okay. I'd like to introduce you now to Mr. Travis Burton. Travis Burton is the USDA Rural Development State Director for Kentucky. Before being appointed to this post by President Donald J. Trump, Travis served as the Associate Vice President of Government Affairs for the Kentucky Hospital Association. There, he worked with state leaders to improve rural health care in the Commonwealth, and previously he held roles with Kentucky Department of Agriculture under former Commissioner James Fuller and the Kentucky Chamber of Commerce, focusing on small business and agricultural issues. Travis serves as a board member for Jobs for America Graduates Kentucky. He resides in Garrard County with his wife, Lindsay, and a kindergarten teacher and their young children. It's my pleasure to introduce you to Mr. Travis Burton.
Well, I'm so excited to be here today. What an amazing operation this is. I do have to give a little bit of a disclaimer. So I am the new Trump-appointed USDA Rural Development Director for Kentucky. This is really my first opportunity to give public remarks. So there's a lot of pressure on me, I feel like. In the spirit of the day, I want to get it right. So in the spirit of the day on the way down, I got on X, Twitter, and went to its AI feature. And I told AI what was going on, what we were about to celebrate. And I said, I need some jokes. I want to make people laugh. Besides just laughing when they look at me. But anyway, I've got 4 young kids at home. I've got plenty of dad jokes, and I've got to tell Elon that he's going to have to do some work on the humor function of AI. So I won't put you all through what it came back with. This is just an amazing day, an amazing first outing as USDA Rural Development Director. To see this operation, we're looking at a new approach to housing and a new way to utilize technology right here at home. And another thing that excites our side about this and our team is the potential, not just for the housing side, but to see the jobs and the opportunity that this technology and the way it's being used will create. President Trump and USDA Secretary Brooke Rollins are committed to ushering in a new era of prosperity across rural America. And the way to do it is what we are doing here today, finding new ways to create jobs, attract talent, and utilize technology. And so on behalf of the administration, we want to thank Somerset for hosting this and their team, Eric's team. Dr. Quarles, thank you. And for all of the state leaders and local leaders who are with us. And how appropriate that this would be taking place in Somerset. My good friend, Mayor Keck, he's here. And one thing I've learned from our friendship and watching him serve in this area is you can do big things if you have big ideas. Now, Eric, you may also agree that in addition to the big ideas, it's helpful to have a little bit of funding along the way. It never hurts. And that's the role that USDA Rural Development, U.S. Department of Agriculture has played. Early on, the team saw the value in Eric and his team and their big idea around additive manufacturing. And so along with the Appalachian Regional Commission and other stakeholders who are here today, we made early investments. And that's what we are looking at today. We are looking at that reality. We are looking at the future. And this, I can't say thank you enough for your vision, for all of the work that went into this. This is going to play a major role in how we move rural Kentucky forward. Thank you all so much for having me. What a great day.
Last bunch we want to get up here. Fred is sitting down here in front. I want to introduce you to Eric Wooldridge, Ryan Cox, and Jennifer Seifert. It is my pleasure to bring them in front of you here today and hopefully answer any questions about the things going on over here, what's in the future, what brought it about, some of those things that happened. First, I want to introduce you to Eric Wooldridge, Professor and Director of KCTCS's Additive Manufacturing Center. I'm going to get all three of you up here at one time. So, you don't want to be waiting over here awkward that way. SCC's Additive Manufacturing Program and was developed under Eric's leadership and created the nation's first statewide additive manufacturing certificate program, training more than 5,000 college students, 250 plus K-12 teachers, and 105 dual credit instructors, while introducing over 10,000 K-12 students to the principles of 3D printing. Next, Dr. Ryan Cox, Director of Skyland 3D and RIC Technology. RIC Technology is a robotic construction company specializing in the integration of advanced robotics, artificial intelligence, high performance materials, and parametric design into the building process. The company's mission is to revolutionize the construction design industry. And finally, Dr. Jennifer Seifert, Principal, Progress Appalachia. Progress Appalachia is rooted in the belief that healthy families, reliable jobs, and self-sufficient communities form the foundation of a prosperous America. Its mission is to rebuild Appalachian communities with practical, results-driven investments in housing, agriculture, and workforce infrastructure. And it is my pleasure to introduce all three of you to Eric, Dr. Cox, and Dr. Seifert. If you would, there's 2 mics up here for you.
Thank you all for coming. This has been 12 years in the making, and I can't say enough about the fact it's the partners. What you're seeing out there and together is what happens when you have public-private partnerships and shared vision. We actually had the statement a couple of days ago. It's about finding the right dance partners and going to do great things together. So at this point in time, we want to offer up just a chance to ask questions from the community. Anything you want to ask about concrete 3D printing, now is the time. The experts are here, and that is not me, but I'll make it sound good if I don't know the actual answer. But we'll have more of it over there as we, meander and see and get to check it all out. So, any questions?
So I actually have 2. So if you could compare the overall cost of using 3D printing to build a home as opposed to traditional. That's number 1. Number 2, talk about how maybe it's more resistant to wind, to flooding. Those 2 questions.
Sure. I'll start with the wind and flooding. One of the things that you technically can't see in the design, and the reason we call it the Floodbuster, is because the shape inside of the wall. We've had the ability to do good engineering for decades. We've even had computer models that could show us why things fail. But we didn't necessarily have, we can't always tell exactly, we can't always build what we design. Now we have a machine that I can give it the most complicated shape, the most weird looking thing you've ever seen, almost organic, and that system will do it. So what we've done is we've designed a structure at the corners of the critical stress points that has a complex weave of concrete in such a way that it resists the force. And we just analyze it through saying, okay, this much wind speed or wind pressure is going to generate an equivalent force, and we design against that. So that's kind of how it resists, even though we're using the same concrete material. That's right, that is true. The handouts that you have, the little mini Floodbusters, you can actually see in the corners the Floodbuster design, and we have samples of it like on the ground that you can see as you kind of come in. And we have them in various stages so you can see where we did it wrong, and you can actually see where we did it right in those cases. So that's actually a great point about additives. It's all about the fact that we can continuously improve. You want to speak a little bit on the cost overall?
Sure. So traditionally right now in America, we're building homes at roughly $180 a square foot to $225 a square foot, depending on your finishes. Here with the 3D robotic printing systems, we're able to achieve an actual value cost of roughly $60 to $80 a square foot. And one of the biggest things is that we're revolutionizing where the workforce is actually applied, right? We're not taking away any jobs, and that's a big piece I want to address as well. But the idea is that we're just training that same workforce to do a different type of job, right? And so we're using those same people, but we're using less of them. And quite frankly, if it weren't for institutions like Somerset Community College, we wouldn't have the ones that we do have right now, right? So all of us know that I would rather be in the air conditioning too. Actually, that's a lie. I'd rather be out here in the heat sweating with y'all. But the costs are going down dramatically as the additives themselves, the cost of the concrete goes down, the price of that house will drop even further. The biggest piece is that house will be printed as that printer moves in 40 hours of print time. So literally that robot doesn't take overtime. It doesn't need payroll deductions. It doesn't need a 401k plan. I'll take it, but it doesn't need all of those added benefits. It doesn't need a break. It doesn't need to stop. It needs to be cleaned up and washed out, and it can keep right on printing. So those costs are going to continue to plummet. You should be able to be within the next 5 years at probably half that price. And that's what we've seen as we apply technology across the board, right? Computers got cheaper and cheaper and cheaper over the past decade, and they'll continue to drop. I don't know why iPhones aren't getting cheaper, but my robots are definitely getting that way as well. So I hope that answers your question on construction costs.
We're also seeing the fact that this has happened already with 3D printing. What we saw in 2013, our very first 3D printer, we have seen what it could do then, and we can do that now with a $200 printer and 3 times as fast and way better. So we know it's happening. In fact, we've already seen
major iterations in the technology thus far. The other thing is we're seeing different environments too. This actually was a project based on the 2022 floods. And now we had an F4 tornado 30 miles a week. So this design is, and pressure is pressure, whether it's water or whether it's wind. So this design is actually probably going to be redefined, not just the Floodbuster, but we're calling it the Stormbuster, because it gets to do the same thing. So, yeah. Other questions? Yep.
Okay, so this is more of an engineering question. When you're looking at a system like this, obviously as it's additive manufacturing, you can't have steel reinforcement in this, which raises some questions with me about potential layer separation over time when you're looking not at direct pressure like wind or water, but with foundation shifting. How does it deal with that?
So this particular one is a foundation that we conventionally did. So your general plan there would be do a good foundation and get your fraud steps, put your reinforcement in. We actually did steel fibers in this slab for testing out how quickly it could be done with less rebar. But you're absolutely wrong. If you don't have the foundation, like any good adage is, it's not going to work. So we spend a lot of time on the engineering side of it, not only just to account for what the printer is going to do with the walls, but the foundation is ready to go to match up for it. Now, we have some capability within the printer itself to compensate. We have, of course, some masonry ladders that get built into it. We also have the ability to embed tensile strength exactly where we need it. Because as that layer is coming around, we have various ways to drop in components between those layers to create additional tensile reinforcement. The other thing that we're doing is we're actually designing the internal structure. So I have tensile resistors. So concrete's not great in tension, it's great in compression. So one of the things that we're doing is we're actually within the structure designing for compressive direction. We've had concrete for 2,000 years, and the Romans didn't have steel, yet we still have structures still standing today. We're using those same concepts to, especially since we can place the concrete exactly like we want, we're using those same concepts to not eliminate steel, but maximize the benefit of concrete. You have anything to add on layer to layer?
Yeah, so the other piece, right, the bonding agents within the high strength grout and mortar that we're currently using are specifically engineered to stick to themselves, concrete and asphalt. The material that was used here today, Quikrete, has been specifically engineered, and the other partners here at the school, Sika, have also been striving very delicately to make sure that they've got a chemical reactive bond within the grout itself that allows for a higher strength bonding agent. So traditional concrete that we're getting out of a ready mix truck is coming out right around 3,500 psi, and adheres and attaches depending on how much water's into it. This has a very specific 16% water additive ratio that has to be adhered to very, very, very stringently. Otherwise, it gets too watery, it won't set up in time. But as this hardens, it creates a bond between the two layers and actually adheres itself due to its chemical composition. So it's like super freeze.
You want to throw in on that, Jen? You can put some technical information. Next question.
So as you continue to pour, do you get a cold charge?
So in terms of like, maybe stopping and starting,
Right.
yeah, we actually do stop and start quite a bit.
Or conventional basis 45.
Yep. So we stop and start quite a bit actually.
So the cold joint can kind of be overcome using the cold joints are overcome using the bonding agent. You do get a cold joint, but you have about a 12 to 15 minute reaction time when you stop and start the robot. So you can kind of move forward and then adhere to it, and then continually move it, or you can re-wet that same material and get that bonding agent to reactivate.
So you can bring it back to life and keep it basically.
Yes, within 15 minutes you can. Yeah. Within a half an hour, I would say we're just going to go ahead and use adhesive.
And that.
Well, that was kind of my question on consistency as far as the temperatures. Like it's a 90-degree day and you're doing that.
Wouldn't know anything about that at all, right?
No. It's 180.
Continue, yeah.
But I just wondered, what do you look like, if it's a 60-degree day versus a 95-degree day? I'm getting that consistency when you're doing the concrete. What kind of factors into that?
We have excellent control on the mixer side. For the most part, the robotic arm is just placing it where we want it to be. That's the engineering and the shaping. The mixer side has extreme control, so we just adjust for ratios when we see things start to happen. You have to his point, he said 16, 70%, we have complete control over that. So it's really a very checklist kind of approach. But to be fair, in terms of the heat, obviously we've been printing this week. It's been a little bit toasty. So we've been watching that. Keeping the concrete cool is actually, after the print, is actually more challenging than during the print itself. I think Wednesday night, it was about 106 degrees at the top surface of the concrete. And it was about 2:30 in the morning at that point. So yeah, you got to watch it.
So I wondered if you had like a cover over it, you know, when you're doing something just to.
You've seen a lot of folks do a lot of different methodology. Fortunately, we just planted these trees a couple of 100 years ago. But we actually, you can put tents up. We've also just done a misting effect to keep it down.
When it's that hot, you add ice to the mix.
You can. We have it on this batch, but it's very common to actually pre-cool the water and go through chilling.
Yeah, many of the systems that we use and integrate in 3D concrete printing across North America definitely use water heating and water chilling systems so that we have greater control over the mixes as it hits the air. And that's the science behind the robotics engineering to allow the material to do its job. So we actually have an engineered water chilling system and water heating system. So we printed in Alabama in February. We printed a Walmart in Alabama in February, and we were heating water. We planted a Walmart in Athens, Tennessee on the surface of the sun at 120 degrees. And the pad slab was 120 degrees, and we were chilling the water at that point in time. So the greater control you have in additive manufacturing, the greater the end product will become, right? And so, we heat and cool.
How about a question about like where things go from here, so Jen can get to talk?
What's next? Eric, what's next? What's next for this?
Jen, you want to answer that question?
Yeah.
Talk about housing being the defining social and technical issue of our time. And these are the folks that obviously clearly know everything about the technology. I bring the social component to the equation. Who gets access to that home? Who gets to live in it? Is it affordable? Is it resilient to extreme weather events? And so I'm always trying to think, how do we make this technology work to heal problems in our region, create opportunities for individuals, and create the opportunity for people to have safe housing, because that is the foundation of home and safety for many of us. So what's next? This is the demo house, but has anybody wondered why everything's Floodbuster 1? Anyone? Floodbuster 1?
We're not creative.
No, it's because there's Floodbuster 2. There's a Floodbuster 2. The RFQ has been released for that, and it is going to be an office at the Bluegrass Veterans Ranch. Where's Virginia and Frank? There they are, back there. So the next phase of this is going to be benefiting veterans that struggle with homelessness. And after that, we'll see other opportunities, hopefully, for this technology to help the people that rarely are the first to receive the benefits of technologies that these folks are bringing to. So that is what's next here in Somerset. But what's next is a development of innovation ecosystems across 7 states in Central Appalachia. Because what Eric and Ryan have been able to do here, we need in my hometown. We probably need up the road. So what we're looking to do is take what they've done here and replicate it, because our neighbors aren't the only ones who deserve to be safe and have a wonderful future.
What is the timeline for that to actually be, what's the timeline for that to actually come to fruition?
Which one?
Well, for it to be utilized by the people who need it.
So like any nascent new technology, scale is going to be the next challenge, right? These folks have proven that it's possible. Now we need to figure out how do we replicate and get that to other communities. So what I specialize in is stitching together these partnerships, these complex partnerships that respond to this very complex problem. And we put these teams together in all these different locations. And so it's really going to depend on funding. We need more funding, and when we have the partnerships, we can bring subsidies or opportunities that only for-profits can bring, or institutions of higher education, or nonprofits like Habitat. And it's putting all of those pieces together with unsiloed funding. That's the trickiest thing, because we need all the pieces. We need the technology, we need the workforce, we need the engineers. So we need flexible funding that creates the opportunity where we can accelerate all those things simultaneously. So the timeline just really depends on how quickly we can get the funding to replicate what these folks are doing here.
Yeah, and scaling too.
Hey Eric.
Hey
How
buddy.
you going? So as a small business,
As a founding member of Additive Across Kentucky, is what we were talking about.
as a business lender and technical assistance provider, how do we take it from this machine is working for SCC to working for ABC Construction or DC Trimble or Gray Construction or whomever?
Yep.
Or who are the construction companies in the state that want to take this and build a business around it, a
Yep.
for-profit?
The answer to that question is a little bit of what you just said too. It's projects. We just need to go ahead and start doing them now. And the more we do right now, the faster it accelerates and the more everyone gets comfortable with it. And more importantly, once it's in the field, the more innovations that come from it. One of the things I want everyone to realize is it's not just about the houses. You've seen some of the other products that are kind of like on your way in and out. We're talking about infrastructure capabilities. We're talking about a whole host of concrete things we can start making. But we just have to start doing projects, big and small, and then it gets it rolling.
Here.
Okay, yes, ma'am.
Yeah, well, some of my questions were answered a little bit, but I'm with Habitat for Humanity, the state office. We have 31 affiliates in 49 counties.
Yes, ma'am.
And this is great here for Pulaski, Somerset. I am wondering, are there any other community technical colleges that are interested in setting up what you all have right now? Because the practical side of this as a nonprofit serving a very, very low income family is getting that machine.
Right.
Whether that is transporting it somewhere, having the expertise to be able on site to do it, which if not, then that's going to raise the cost, as well as, you know, still having a place for our volunteers to be able to do things. That's a huge part of our program. And also the sweat equity, we call it, or that community outreach for the families, which serves as those hours that they put into building their own house serve as a down payment on that house of their time and them learning. So all of these things, but I'm thinking right now, what does that machine cost? Is it a nonprofit that's going to have to kind of put out the money to do that if we really want to expand this program across the Commonwealth for all of our people?
So I track all of what you're saying, and first off, let me celebrate Habitat's mission. I don't think it'd be possible to have this house without Habitat for Humanity's involvement here at Somerset Community College. Secondarily, it is a hybrid model that fits between your question and his question.
Yeah.
How do we get the construction companies involved? So here at this very school today, you've got a tribally owned 3D concrete printing company here out of Oklahoma. You've got a robot manufacturing system, and I represent both. So in order to gain him access to projects, I have to be able to bring the opportunity to a capital-based organization. I have to have the ability for a construction company to make money on it. In order for me to sell a robot or rent a robot or lease a robot, I have to have a project for that robot to go do. Because otherwise it's a very, very expensive paperweight. Now it will build a Ford truck and it will build a, something Ram Tough if you want. It's the same robotic arms and technology that are applied there. However, in order to get those projects off the ground, those same capital intensive projects that Habitat for Humanity is already doing can be approached from a for-profit perspective and worked in conjunction with. So we know as a robotics manufacturing company that we are willing to support every project that we possibly can in the United States that offers affordable and attainable housing for populations in distress, whether that be here or anywhere on planet Earth. God didn't say we couldn't help others anywhere. right? So like you said, we're in Kentucky, so I can talk about God. So it's still legal, right? Right. Amen. Amen. So so in conjunction, what I'd like to say is we're here to help find a way. And what Jen spoke about with the pathways, we found a way to get it here, right? The truth is we didn't have we had the design, we had the structural engineering, we had the gumption, we had the know-how, but we didn't have the robot. Well, then the robot guy walked in and said, hey, you guys got everything I need, and then how do we partner together to do something great? And then rural development said, hey, we want to help you in additive manufacturing kind of overcome this problem for Floodbuster, because there's been a storm here. So bringing all of that together took this team down this pathway so that we could create opportunities for contractors, as you mentioned back here, to support endeavors like yours. But you need to print a couple really big warehouses to pay for a couple really nice livable houses, right? So it takes that hybrid blend across the board in order to engage appropriately.
And the scaling capability too is on the workforce side.
Yes.
You know, so the best part about this is we represent not Somerset, we represent KCCS. So everything we develop out here gets to go to all of our sister sites. Then it's just a matter of getting the funding, the financing to place one of these robots there, and then create those public-private partnerships that make it usable within the communities. Because we've laid all the groundwork. In fact, the curriculum and everything's already ready to roll. It's just a matter of starting to scale.
And then just a couple more comments, I'm so sorry, but a lot of the funding that Habitat accesses is through our State Housing Finance Agency, Kentucky Housing Corporation. Will this meet code?
Absolutely.
Absolutely.
Okay, just need that because there are lots of, hoops we need to
A lot of
do.
codes, a lot of them.
Yeah, absolutely.
So it would help you to know too that we work through the local jurisdiction and the state jurisdiction on this process and talk through these things with them, even set up a plan for a mock review going forward and doing testing. So the offices are aware of it, not only aware of it, but also wanting to participate in the development of it. Now, it's one of the things that's kind of unique in our situation. We actually had the engineering and architectural expertise to provide the licensing to allow it to happen, to make folks comfortable. But, there's actually some pathways within the code. So we can make that happen, and that won't be the barrier.
One thing I do want to add too is the vigilance that these folks have been utilizing, because when we're deploying this technology to the most vulnerable, they are not guinea pigs. Right? We are not testing unproven technology in the folks that need our support the most. And so much time and effort goes into making sure it's safe and attainable and designed to serve that community and that family. So just wanted to add that.
So kind of reiterating what you said earlier about not trying to replace workforce and the workforce curriculum you've got here at KCC, KCTCS. I think within the manufacturing world, we hear a lot that automation, robotics, additive manufacturing is here to replace employees. But that's not the case at all. It is a matter of upskilling, filling holes where we can't find employees. And can you address that a little bit and what that looks like in terms of a career pathway for students, for incumbent workers, and for those folks that may have an interest in getting something like this?
Absolutely. The technology, whether it's concrete printing, plastics, metals, it's a new way of manufacturing. And it's a way of manufacturing things we could never manufacture before. So what we typically do for folks is say, okay, you want to go into a manufacturing field that's high tech and everything, everything's part of like what you see in the movies, this is the way to go. So we allow folks to actually get a certificate in additive as an add-on. Now, those of you who've had some dental work, there's a good chance that was 3D printed in the office while you're away. And they want to hire a dental technician. They don't want to hire an additive person. They want to hire a dental technician that knows additive. We want welders that know additive. We want machinists that know additive because it is an enhancement to manufacturing. And all the next generation products, especially the ones we're seeing in aerospace, are enhanced by additive because it makes things we could never make before. So no, it's absolutely a new pathway for new opportunities and jobs, not a replacement at all. Yes, sir.
Kind of the
dream scenario for the community, the state, and the region?
Say that again, maybe a little bit louder.
Yeah, sorry. Like, what's the dream scenario for the state and the region? Expand
Full potential. I'm gonna get dreamy out there for a little bit. Yeah. So what you're looking at is better engineering, better construction, everything that can last. I mean, look at some of the sections of the world where concrete is their only source of building materials. We're talking about buildings that last 400, 500 years. And that right over there can last 150 at least. So the dream is not only do we actually have the ability to make customized homes for folks, you can actually create on a phone what you want to live in, and a robot puts it together. And you can actually get insurance because it's non-combustible and it'll survive everything. And when you actually walk in there and you can feel the sense of safeness, you can feel the mass around you. It's just a better experience. So you're going to be having the opportunity to live in a home that you potentially designed yourself, made by a machine, made by the most advanced technology out there. It's energy efficient, it's safe, it's secure, and it has a huge number of outcomes. But then you're going to be sitting around in your house and you're thinking, man, this is pretty cool. But it'd really be cool if I had it do this. And guess what? It can. So you'll be able to enhance. Again, I talk about the concrete products because now we can create a new line of things we've never thought of. So the dream is very big. It's not just the houses, it's all of the small businesses that can start up around this technology right now and start making new things. So for example, this is printing a house. Over the weekend, may not be running. Why not put it to producing a product you can sell? And then maybe actually take your printer to do something else. There's a great, you have a partner on the West Coast that's making swimming pools, correct?
Yep.
Customized spa. Stop. Who doesn't want that?
I'm good
95
degrees today.
But yes, it's everything because this unlocks so many potentials.
So I'd like to add my dream, right, to, I'm not a additive manufacturing guru like Eric. I don't want to see any more people get wiped out by storms. So this house that's right here before you, we're talking 140, 170 mile an hour wind speeds. They can withstand that, right? We're talking about a 3-foot wall of water cascading down a riverbank, right? We're talking bridge blows out. This thing can take an impact of about 200 miles an hour when it's built properly, right? I personally set one of these things on fire in Houston 3 months ago.
Technically, it didn't burn.
Technically, it doesn't burn.
It doesn't burn. He had to put stuff next to it to burn.
Yes, and I use the fire department. I am reckless normally in my daily job, but I use the fire department for that because I was on TV. But they literally had a 1,390 degree propane torch on the outside of the building for an hour. And on the other side of the house was 65 degrees. Well, we've got fires in Hawaii. We've got fires in California. We got flooding in Kentucky. We got flooding with my hometown, Tennessee. We got flooding across western North Carolina. I got storms and hurricanes hitting all over the place. The weather's not getting any better, so housing's got to react. Period. I drove up this road to see this place the day of that storm because where that young lady lives in Oklahoma is where that storm front started and tore off buildings in Oklahoma, and then stopped off in Little Rock and smashed a few there, and then went up to St. Louis and knocked out some there, and then caused terrible flooding in the middle of one of the most metropolitan cities in the Midwest. Then it lands up here in Somerset, Kentucky, puts a 3-mile swath of some lady's freaking roof across the highway, and the people are crying because they're stopped in freaking traffic. Whoops, I'm sorry that I really inconvenienced you because my family has just lost its place to live. Climate resilient housing is an action that needs to be taken. That needs to be done. We can engineer smarter. We have smart engineers. This isn't Carnegie Mellon. This isn't MIT. This is Somerset Community College. We're applying the actual engineering to the actual construction, and it's saving lives. 19 people lost their life up here. Across that entire storm system, the numbers were in the hundreds. Could it just be 99 next time? Please? That's what my dream is. Cool.
With that in mind, as part of the design, and we have time for one more, but with that in mind, is rolling out the storm shelter design so that we can integrate with this. I mean, it can do it all. We just have to start doing it. So we have time for one more. We will answer plenty of questions as we go on, but I want to let everyone start to go see things.
Yeah.
But one more question, ideally one for Jen. Yep.
Multi-part question, is this actually going to be a home? Is somebody actually going to live in here?
I'll give it a quick one. The answer is no. This is on state property, so I can't let anyone live in this thing. We are going to do all the testing for Floodbuster 2 that's coming up for that exact reason. But we'll use the test site.
Is it going to be monitored in any way for heating and cooling load versus, R value?
Sure. So we'll do not so much monitoring, but we'll actually do the testing for that, isolated testing. It is concrete, so we have some of those numbers, but we'll be doing a variety of different insulation checks to go through it to figure it out. We also will be putting the roof on it as well to test it for, basically some uplift loads and also thermal load with that too. So yeah, it'll go in.
When will these classes start in college? When will they start?
We will probably be offering workforce classes this semester, specifically customized training for this. Yep. Big picture question for Jen to wrap it up. All right, in that case, let's go see the robot. We'll be milling around. You can check it all out, ask us questions. Thank you all very much for coming. Thank you.
might want to come forward a little bit,
Okay.
low light. Is that okay now?
Thank you all for watching. For those streaming, this is Floodbuster 1 at Somerset Community College. You see, of course, behind me is the house being printed as we've been working on it this week, and a lot of you have been calling that, which we do appreciate your interest and also your support in talking about the technology. One of the kind of funny things is yesterday we actually had a part break. Fortunately, this is additive manufacturing, so we 3D printed a replacement part overnight and actually got it running this morning. So that's the nature of the technology, that it can do what you design and it doesn't really say no. So what we're going to be using this for in terms of homes and infrastructure, it's the same mentality we can use with a typical 3D desktop printer. So I definitely encourage everyone to kind of really consider the technology, think about what you can do with it, learn about it too. Heck, you can always take classes with us anytime you want to. We're remote 3D printing courses that we offer. But just realize that anyone can use this, whether it's big or small, and this is a technology that can actually save lives. Part of what we'll be doing in going forward is obviously designing more homes across the nation with this technology, but also be looking into storm shelters that can be integrated into the environment and also integrated into like an existing home structure. So again, thank you all for watching the process, and let us know if you have any questions.